after testing. This comes back up in this unit as well. Okay, so now that you're done, you keep moving on. So you gotta know this, if there's no number in front of the x squared, most of you from what just going around are getting this. Jalen, what'd you get for number one?
X plus 6 and X plus 2.
X plus 6 times X plus 2, because you're looking for two numbers that multiply to get 12 and add to get 8, only when there's no number in front of the x squared, so that's fine. It's X plus 6 times X plus 2. You can, and if you want to, I know some of you will still do the grouping method. You'll do this, and then you'll take out an X, and then you'll take out a 2. That's fine. It's a little bit overkill if there's no number in front of the X squared, but it'll work. All right, Jay Lee, did you know how to do number 2? Yeah? What'd you do? Okay.
2x squared minus 12x plus 3x minus 18.
Okay, hold on right there. That's excellent. All right, so now for this one here, when you got when you got a number in front of the x squared, two numbers, sometimes you can't even find two numbers that multiply to negative 18 and add to negative, and they're probably not going to be right anyway. Okay, you got to do it this way, and this is what we went through. Some of you do guess and check, but most of you go through this. She did exactly right. 2 times negative 18 is negative 36. Come up with two numbers that multiply to negative 36 and then add to get 3, or excuse me, negative 9. It's negative 12 and 3. Then what'd you tell me to write there, Jaylee?
Was the 2x squared minus 12 plus 3x minus 18.
All right, now I'm just going to wait. Get that down if you don't have it down. Okay. 2x squared minus 12x plus 3x minus 18. And then, so you group, and what's your GCF for the first one, Jaylee? 2x. And so that gives me, what do I get when I divide by 2x? Yeah, I'm just going to put x. You can put 1x. And then you get a GCF of 3. And you get x minus 6. So the x minus 6 comes out. And you should get 2x plus 3 in the other one. All right, so that's your answer. And like the order can be flipped. The order can be flipped. All right, Joe, did you follow that? Yes, okay. So, Joe, what would we do for number 3 first?
4 by 15.
4 times 15 you would, and that'll give us positive 60. And now we want to find what multiplies to equal positive 60 and adds to get negative 16. Okay, so for those, now do you know the two numbers that multiply to 60 and add to negative 16?
Negative 6 and negative 10.
Good, negative 6 and negative 10. Zane, what do I do now?
Rewrite it.
Good, as what?
4x squared minus 10x minus 6x plus 15.
Okay, the 6 and the 10 are interchangeable. If you did the 6 first and the 10 second, it's absolutely fine. Just so your work will show up just a little bit different. And now, all right, as you take a look at those two. All right, GCF of the first two, Christian.
2x.
And then what should I write in parentheses behind that?
2x minus 5.
Okay, I agree. All right, GCF Grant of the second pair.
Negative 3.
Good, you do need to include the negative. You want to make it negative 3. And then what happens when I divide by negative 3?
2x minus 5.
2x minus 5. And so now I get 2x minus 5 times 2x minus 3. All right. We'll do a couple tomorrow as well. Can't forget. You can't forget. And then, we may even just have a little quiz sometime this week over just 3 or 4 of them. just because like I said, we gotta keep remembering those. Homework wise, all right, I said to do this on your homework. For 22 and 24, you need to show me your work. Most of you did, you did a table, and you showed the subtraction that you have to do. If you did, make sure you make a note that you gotta do that. Because the second constances are not constant, I can't tell that unless you show me those steps. Zip it. And then and for 24, the second constants are the same. What number do they come out to be? They all come out to be 2. Is that right? Okay, so that should be the case. 26 and 28. Most of you graphed, a few you didn't. For 26, Hanan, what did you get for your chart?
-2, -1.
0, 1, and 2. Did you use that? And what did you get on for the y values?
-1, -4, -5, -4, and -1.
Okay, make sure that's what you should have when you graph that. Okay, you should have that chart. And I believe it's y equals x squared minus 5 is the equation. Okay, for that. And now, for the second one here, x, y. I'm trying to think. Sam, did you have that graph?
Yeah,
What did you get for your chart then?
I got, should I just tell you the Y's?
Yeah, let me hold on. Let me write this. What did you get for the y's?
I got -6, 0, 2, 0, and 6. And -6.
Okay, yep, that looks right. Okay, that looks right. So make sure you have that chart. 30 should open up. 32 should open down. 34, your vertex, write it as the point 1, -3, maximum of -3. Domain, all real numbers, range y is greater than or equal to 2 for 36. 38, domain, all real numbers, range is y is less than or equal to 4. 40 is never, 42 should be sometimes, and 44 should be always. All right, now I'm gonna do something here. Okay, even though you didn't have to, take a look at 39. The graph of a quadratic function is a straight line. The graph of a quadratic, always, sometimes, or never. Okay. Josh, what do you think?
Always.
You literally just showed me.
Function, straight line.
All right. What's in a quadratic? Now, we just graphed.
No, never mind. It's you.
It's a U. Okay, good. So it is a U. So is this going to be always, sometimes, or never?
No.
It's going to be never because it's a U. Okay, it's got to open up or down. The highest power in a quadratic function is 2. The highest power in a quadratic function is 2. Connor, think about that. What does it mean by power?
It means like a little number above the variable.
The little number, also called an exponent. So what do you think this would be? Always, sometimes, or never?
Always.
Always, yep. Highest power is always 2. So that is always. And for 43, the vertex of a parabola occurs at the minimum value of the function. Joe? Sometimes. Because can anybody tell me what yes, it happens, but when would it not happen?
There's a maximum.
When it's at the maximum. So it could be at the minimum or maximum. Okay, good. All right. We're going to move into 9-2. I got some guided notes for you. Let me hand those out.
Why did you get that? Why isn't it a big question?
It was gonna be the balloon one. Balloon boy.
Oh,
We need to-
No, actually.
Because they wouldn't take you serious.
Yeah,
They don't act-
I put all of that.
Yeah, that's right.
We're not close.
We're in math class right now. You know that.
I need like one of them little.
Oh, okay. That's what you meant?
That's how they be like.
Oh, yeah.
Oh, I got.
Like, you know how Paul is now, sister? Young kid. Robin, you know, that's right.
You come in, you come in. You give the mic out, intro, go.
All right, listen up here. Couple things we want to do. Find the zeros of quadratic function and find the axis of symmetry. We're gonna wait on the vertex for tomorrow. Axis of symmetry, you may even have no idea what that is, that's fine at this point. Zeros really aren't that difficult when we go through it, but you gotta understand, and it's kind of a big deal kind of from here on out. A zero of a function is an x value that when you plug it in, makes the whole equation equal to zero. So just a really quick case here. What would be the zero of this function? What x value would I plug in to that equation to make it equal zero? Christian? No, because if I plugged in zero, I would get back 4. Okay, doesn't mean it's equal to 0. Oh,
-4? Or
nah,
-2?
-2. Because what's 2 times -2? -4. -4 plus 4 is 0. So that means when I plug in -2, okay, I get back that answer. Now, for a parabola, it's going to be a little bit different. What we're going to do is we're going to look at where it hits the x-axis. Those values are our zeros. Same idea. When you plug it into the equation, you get back 0. When you look at the graph, you look for the x-intercept. So a zero of a function is the same as the x-intercept of a function, okay? A quadratic function may have 1, 2, or no zeros. All right, so right there, you got a little bit, a gap. See where it says a quadratic function may have 1, 2, or no zeros? Draw the case where it has 1 0. Just do a rough sketch, draw that. Draw the case where it has 2 zeros. And draw the case where it has no zeros. Okay. So what does it look like when it has 1 0? It means it's parabola that opens up and it just hits the x-axis 1 time. Okay, and then put 1 0 beside it or below it or somewhere.
Yeah.
Right? No, right in that gap.
Wait, where did we write this?
Right in that gap, right above where it says example 1. Yep, right in that gap. Here. And so it should make sense that, it could just hit 1 time. It could hit 2 times, or depending on how it's moved, it could hit 0 times. Okay, so those are going to be your 3 cases. Make sure you draw that. So you got 1 0, 2 zeros, or no zeros. And then looking at the graph, it's usually pretty obvious from that. Now we also call 0 x-intercept. So when you plug it in, it's going to make the function equal to 0. All right, now this is where that says example 1. Like I said, this should not be difficult. From the graph. Now, I want you to identify them as ordered pairs. Christian, what do you think? What?
Can you go back real quick?
Yeah. All right, Christian, I'm gonna move on here. I'll go back if I need to at the
No, I'm
end.
good.
All right, so for part A, Allie, how many zeros does it have? 2. Now, it says, find the zeros. So I want you to actually list them, and I want you to list them as order pairs. So for this one here, it's -1, 0, because the y coordinate is going to be 0. And what's the other one? It is 3, 0. So those are the zeros. And that's all you got to do. Okay, so if you got a graph, life's pretty easy. For that second one you got there, Tommy, how many zeros does that second one have? One. Okay, what would you label it?
I don't know.
All right, well, how many, right here's your x-axis or your y-axis, and just count over 1, 2, 3, 4 to the negative. So just list that as -4, 0. Okay, for that 1, 0 on that. And that third one, Evan, how many zeros does it have?
0.
It has 0. Okay, so no zeros. All right, if a parabola has only 1 0, the 0 is the x-coordinate of the vertex. Okay, so right here, the vertex is an important point. That's the same thing right here as the vertex is the same as the x-intercept, okay, or the 0. So that can happen. Axis of symmetry. Okay, it is the vertical line that divides it in half. Okay, it cuts it in half. It has to go through the vertex. Okay, so if you look at that little graph there, if the vertex is right here, the axis of symmetry has to go right through it. The axis of symmetry is always an equation that starts with x. Vertical lines always have an x. We talked about, it's been a little while, but we talked about like x equals 3. So it's going to cut it in half. If it's not, if there's 2 zeros, basically the axis of symmetry has to be halfway between the zeros. It still has to go through the vertex, but it has to be halfway between that. Now you're not going to do this too often, but if you do get some ugly numbers, you basically add the -4 plus 0, and then take half of it, you get -2. More often than not, you're just going to be able to look at it and tell me what it is. Okay? So right here, find the axis of symmetry. Now, it's real important how you write it. And actually, yeah, go ahead and flip over. You're going to be on the top of the next page. And it doesn't hurt. I would go ahead and draw it in. Now, the axis of symmetry should be a dotted line. It goes right through the middle. And I'm just going to put axis of symmetry. All right, how are you going to label it? So there's a right way and a wrong way to label it. Okay. Preston, what do you think?
Would it be Q for some reason? I don't know.
All right, hold on. I'm going to go back for a second. This axis of symmetry is written x equals 3.
So would it just be -1, 0? Or -1?
This axis of symmetry is x equals -2.
So x equals -1.
There we go. You have, yep, and you have to do that. You have to say x equals -1. Okay, not just -1, not -1, 0. X equals -1. Okay, make sure you got that. Morgan, what about the second one? What do you think? 2.5, good. What you notice, this doesn't hit at the perfect spot. Doesn't hit at a perfect point. You want to go right through the vertex. Basically, your symmetry axis symmetry has to be halfway in between those x-intercepts. Well, the first one's at 1, the second one's at 4. Go halfway in between, you're going to get 2.5. So you say x equals, you can say 2.5 or 2.5. It really doesn't matter. Okay, for that. So that would be 2.5. All right, identify the axis of symmetry for the next two. Draw it in there, write down the axis of symmetry. Joe, what do you think for the C there? For the axis of symmetry, how would we label it?
Would it be like the M? I have no idea on that.
All right, thank you. Look back at these other two, which I'm sure you wrote down. Okay, you just gotta say X equals, and then it's gotta be a number. And then basically, how do we get that number? That number is the X coordinate of where it crosses that point.
Okay.
So if you take a look at C, what do you think it's gonna be?
What would the M be?
It's gotta be something.
Well, X equals 1.
X equals 1. X equals 1 would be correct for that one. And then, Jay Lee, how about D? X equals -3. All right, make sure everything says X equals. Okay, for all of those. And it's just identifying. There's really no work to do unless it doesn't hit in the middle. And then you kind of just take the average of the X's. So that you do 1 plus 4, which is 5 divided by 2, you get 2.5. All right, now take a look at this one here. What's the axis of symmetry of this one? Okay. What's the axis of symmetry of that equation? Morgan?
I don't know.
Yeah, you don't know, because you don't have the picture, do you?
No?
Christian,
Is it X equals -3?
where are you getting that from?
I don't know, I just.
Made it up?
What, no, I just subtract the 2 and then split it in half.
Alright. No, we don't know what it is, do we? Because this one here, you got a picture, it's obvious where to draw it. If you don't have a picture, it gets a little different. Okay, now there is a formula, which is right there in the middle to figure this out. Okay, so if you take a look right there in the middle, what is the formula that tells us what the axis of symmetry is? Okay, Christian?
X equals -b over 2a.
Good. X equals -b over 2a. Now you got, what is the b and what is the a? They show you right here. The b is the number in front of the x. A is always the number in front of the x squared. Once you get y by itself, now 9 times out of 10, y is already going to be by itself. Okay. So now that's how we figure out the axis of symmetry. If we don't know the, if we don't have the graph. Whoops. Okay, so for this one here, you're going to say, write down the equation, x equals -b over 2a. You got to be able to identify the b and the a. All right, Sam, what do you think here for the b and the a? Any ideas?
Oh, would be -4.
Good, the b is -4. What about the a?
Would that be -4?
No, a is in front of, what's the a in front of?
Oh, X squared.
X squared. So what number's in front of that x squared?
Oh, 1.
A 1. So you got to make it a 1. So we got x equals -b over 2a. So put the negative, and then b is -4. 2 times 1. The main thing is you just got to watch your sign. You don't make it negative when it should be positive, whatever. Well, minus negative is going to be a what? It's going to end up being a +4. 2 times 1 is 2. So this is going to be 4 over 2, which is 2. So in the end, I get x equals 2. That's the main thing is you got to watch. If the b is a negative, it's going to turn into a positive because of the formula for that one. Okay, for this one here, y equals 2x squared minus x plus 3. Connor, what's my a and what's my b?
Your a is the 2, and your b is the -x.
Not -x, you would never
It'd be -1.
say -1. Good. And so now x equals -b over 2a. So it's going to be opposite of -1 over 2 times 2. All right, minus a -1 gives me 1. 2 times 2 gives me 4. Just leave it as 1/4. That's fine. Okay, just leave that. It's not always going to come out to a whole number. And then, whoops. For C, all right, if you think you know what to do, see what you come up with. It'll be a fraction. All I'm gonna ask you to do is reduce it. If you're not quite sure, just wait a second.
Kind of clean B, but I don't know if you
All right, you're not paying attention to this?
have
Yeah. Okay, all right, well, watch what I'm doing. Is the A is 2, B is -1. Okay, so -1 goes in there, 2 goes in there. You got it right, X equals. Okay, for that one. Okay, and then substitute in those numbers.
No, give it back.
-1 for B, and then A is 2. Josh, what's my A and what's my B?
Your A is gonna be 3x. Right? -3x.
Just -3, don't even put the X with it. Okay, what about the B?
10.
B is 10. All right, -B over 2A. So, Grant, tell me what to put in here.
10 over 3, or -3.
Well, that negative has to go in front of the 10, right? So -10 over 2 times what?
-3.
2 times -3. Okay.
Oh, man.
All right, 2 times -3. So we get -10 over -6. All I said was do is reduce that. A negative divided by a negative. Is that positive or is that negative? Negative divided by negative always has to be positive. What's 10 over 6 reduced to? Just leave it as an improper fraction. It's fine because 2 will go into 10, 2 will go into 6, 5/3. That should be your answer. All right, 5/3. X equals. Bryson, you got it? Yeah? Okay. All right, so that's our answer. This is our axis of symmetry. What this tells us. All right, what else can you tell me about this graph? Does this open up or does this open down? Sam, open up or open down?
Open down.
It opens down. 5/3, which is 1 2/3, which would be right about there. That's going to be the axis of symmetry. That's going to cut it in half. That means my vertex is going to be on that line. Then somewhere, and I don't know where it's at, but wherever it is, it's going to go up through that point, and then it's going to open down. Okay, so there's a lot of information we can figure out from just looking at this and understanding what we have. So X is 5/3. Now, I don't know exactly where it's at, but I do know it opens down, and I do know the vertex has to be on that axis of symmetry. All right, I wanted to give you a little bit of time here. It's not a long assignment. So page 603, just do 3 through 12.
All the way 3, 2, 3.
That's it. 3 through 12.
And you made it. Yeah.